we must go on. In former class, we talk about flash memory problems. Please see, there are two problems, but one problem we can see flash has a limited number of program erase cycles. Erase is refresh because the flash memory we find the memory had to erase. So the erase cycles in former we find that the erase cycles is 10,000. In current, the erase cycle has become big and big, and become big is a good thing. So the solution is apply where labeling to distributing writes evenly. So we can move frequently written data around, or create a map from addresses to real locations. The second solution is like about how much space you have. One is sell a 100 GB SSD that secretly has 120 GB. Slowly move memory over as sections back, so you can find SSD size of the SSD. The current size of SSD become big and big. The current size is 128, even 505. This size is big. Whatever the cost, we can see 1 terabyte. Yeah, 1 TB SSD is in market, but this size, this cost, this price is very big, is very high. So populate this size and this size is current size. Okay, this is some original iPod. iPod is one devices from Mac company. My daughter tell me she want to buy one iPod. So I search the parameters and the shortcoming and the good things from the iPod. I find this is the current iPod. The iPod is like without cell phone. So this is one entertainment device. My college tell us some foreign people like iPods, but the Chinese don't like iPods. So iPods, the sale of iPods in China is very low. Like me, like some teachers and classmates, Chinese classmates don't like iPods. So I find that iPods is current for entertainment. You know? Yeah. So I must tell my daughter. Even my daughter has a cell phone. Her mother don't like her use cell phones. So my wife tell me you must buy an iPod to replace the cell phone. You know. So I have a problem. Yeah. But iPod has the flash memory is current. Even you must find Toshiba is one company to product the SSD. Toshiba is a famous company in Japan, and Toshiba, the products of Toshiba is very good. This is the classic iPod. This is the current iPod. Even in iPod, we can see news from some apps. So the iPod hasn't cell phone, but it has even other things. Okay, smartphones use flash memory. This is correct, and this is correct things. This one is Apple A4 chip. In current Apple CPU, the size, the symbol of Apple CPU is A1 and A11. This is the symbol of Apple CPU. I must find in Apple class the symbol of the chip is what is the chip. Okay, this is the flash memory. This is camera, LED flash. This is headset jack, and this is volume control, and this is the battery. The former cell phone, my former cell phone is Apple 6 SP. I replaced twice line battery because the line battery, the life of line battery
It's
2 years.
Yeah,
It's 2 years. So even when the 2 years is become, I must replace the line battery. I find if I replace the line battery, the cell phone is refreshed or is erased. So the cell phone, the line battery is one important component for the cell phone. So you can find this is some 3G in current. This is 5G. So you know this person is the creator of Apple. Jobs. Yeah. But Jobs is dying. Yeah. So this size, this image is from some years ago. Okay, this is some image from the historical of computer memory and storage. You can find this is DRAM, this is flash, this is disk. You can find 3 colors trends. We can see this is DRAM, flash, and disk. This is the year from the 1955 to 2020. Yeah. So you can find the trend is become low and low, and even lower. So we must think, we must trust the cost must be lower and lower. If the cost is become lower and lower, the memory is become useful and useful. So we like the flash and the RAM and disk. Okay, this is some example. This is one SSD. This SSD is very small, so this is for laptop. Yeah, you can find this is from Intel, and this is the series, and this is size. Tell us 505. Yeah, so you can find this is one SSD for laptop. And this is some software. This is for some software. This is SSD. This is for disk, HDD. So you can find the speed, app open times. The speed open times is become small and small. This is 1.8. This is 31.9. So you can find SSD is effective device for increase the laptop
speed.
Yeah, performance of laptop.
Yeah.
Yeah. Compare the driving types, we can see HDDs and SSD. We can find from some access types, durability and noise, relative power, cost, capability, other problems, and lifespan. This is for some. This is the effective, yes, 3 to 5. But this is my laptop. My laptop is 5 years. I buy this laptop in 2015. So this laptop I used for 5 years, but I find SSD is ineffective. How to use is important. So this isn't very, in fact, this isn't very current. Okay, we can see communicating with memory. This is map I/O. What do we need for I/O input and output to work? This is some image. This is one image to describe some devices. This is keyboard. This is disk and the camera and the screen and some devices. This is some entertainment devices. Okay, this is the bus. This is the bus. According to the bus, we can know some devices transmit the data to the memory. The main memory has the data. Then the computer can calculate or can work. So we can find a way to connect many types of devices. So the I/O input and output devices have many types, many. So if you have time, I recommend you can go to the computer markets. Yeah, in Changsha, computer markets have several and very focused in Changsha railway station. No, please remember, it is not Changsha South railway station. It's Changsha railway station.
Yeah. I went there.
Yeah, this railway station is in the center of the city.
Okay.
Yeah, so in the computer market, you can see some types of devices, and you can see some devices. You can see some devices can control the. You can see a way to control these devices, respond to them, and transfer data. A way to present them to user programs so they are useful. So the devices can work, and this devices is very important. Okay, this is instruction set architecture for input and output. One question is, what must the processor do for I/O for input and output? You can see input can read a sequence of bytes. Output can write a sequence of bytes. So bytes is the size for input and output. So we want to increase the speed of input and output. So the size must become big and big. So the bytes is correct and effective. Some processors have special input and output instructions. So you can find this is for some alternative model used by RISC-V and ARM. You can see can use loads for input, stores for output in some pieces. MMIO can call memory mapped input or output. This is MMIO, mapped input or output. A portion of the address space dedicated to the communication path to input or output devices This is no extra memory there. Okay, this is memory map input and or output. Certain physical addresses are not regular memory. Instead, they correspond to registers in input or output devices. Loads and stores can read or write to the device. So you can find this is the device, this is the address, this is the physical address, this is the some details in this section. We can find that they can be divided control register and the data register. So this is the two sections in this section. In one section, there are control register and data register. Okay, this is some examples for memory maps. You can see in microcontroller designed for embedded applications, flash from this section, RAM at this address, memory map Pahero start as this address. So you can find this is some addresses. This is some addresses, and this is we can see reserved is reserved is don't use. UICR, FICR code RAM and the flash is in some sections. Processor input and output speed mismatch. We can see 1 GHz microprocessor can execute 1 billion load or store instructions per second. So you can find the speed is very, very high. You can find this is the data rate, but this is the bit. We can translate it to the byte, and this is we can translate the K to the G to the T. Yeah. So this speed is high. Okay. Recall is I/O devices data rates range from less than 1 KB per second to more than 1 million KB per second. Input, you can see device may not be ready to send data as fast as the processor loads it. Also might be waiting for human to act. Output, you can see device may not be ready to accept data as fast as processor stores it. Okay. Processor checks the status before acting. This is important. Patch to a device generally has two registers. One is control register, two is data register. Control register says it's work to read or write. Data register contains data. Processor reads from control register in a loop, waiting for device to set ready bit. Ready bit is from 0 to 1. From 0 to 1 often describe the turn on. Turn on is become 0 to 1.
Yeah.
So you can find if I kick the controller, you can see become 0 to 1 is effective. Processor then loads from to or writes to data register. This process is called polling. Polling can either loop wait or if timing is known, poll at frequency. This process is called polling. Okay, this is some example polling in assembly. Assembly language. This is assembly language. You can see some. This is input. This is input. This is output. Input can read from keyboard into A0, MMIO at T0. So you can find the wait loop. This is some loop. You can see we can find this is wait loop, and according to the load instruction, we can input some content from keyboard. Yeah, the keyboard. If we pick some content from keyboard, the content can input the computer. Output can write to display from A0. Wait loop is the same from some. Okay, you can find the wait loop is effective. Okay, cost of falling. We can see processor specs is 1 GHz. 1 GHz clock, 400 clock cycle for a falling operation. We call falling routine, assessing the device and returning, determining this symbol of processor time for falling. In mouse, hold 30 times per second, so as not to miss user movement. Hard disk can transfer data in 16-byte chunks and can transfer at 16 MB per second. Again, no transfer can be missed. So, this is the point. Okay, mouse falling, disk falling. We can see this is some calculating method in mouse falling and disk falling. Okay, we can see the interrupts and the DMA. This is some method for input and output. Yeah. Interrupts and DMA is very important for input and output. Alternatives to falling. We can see wasteful to have processor spend most of its time waiting for input and output to be ready. Would like an unplanned processor that would be invoked only when input and output device is ready. Solution is use exception mechanism to help trigger input and output. Trigger is like a controller. Then interrupt the program when input and output is done with data transfer. So please remember interrupt or interruption. Interrupt mechanism is for exception mechanism. Exception is very important for computer. We don't know whatever exception, whenever exception. So we must design one mechanism to salute the exception. So this solution is interrupt. Okay, common exceptions. What's the most common exception we are used to as C programmers? This is some exceptions. Exceptions and interrupts, you can see unexpected events require change in flow of control. Unexpected is the characteristic for exception and interrupts. Different ISAs use the term differently. So you can see exception, interrupt, and trap is three. One is exception arises within the CPU. You can see, for example, system call, invalid memory access, illegal instruction, overflow error. This is some problems. and these problems are exceptions. So if we find the illegal instruction, the exception must occur. And if the exception occurs, we must use the interruption mechanism to describe or to salute the exception. Interrupt from an internal input or output controller, or from current program, or you can find the interrupt can handle whenever it is convenient, though don't wait too long. Check. You can see action on servicing interrupt or exception by hardware jump to handler code. So we can find that dealing with these without sacrificing performance is difficult. Okay, this is checks, interrupts, exceptions, an internal, external, or internal event that needs to be processed by another program. The other program is the OS, operating system. The event is often unexpected from the original program's point of view. This is the trap handler. Okay, passive traps. Trap handler's view of machine states is that every instruction prior to the trap one has completed, but that no instruction after the trap has executed. The handler should return by restoring user register and jumping back to interrupt instructions. Doesn't need to understand any context. The context is pipeline that program was doing, for example. Okay, this is exception steps. You must see. The step 1, unexpected event occurs. Step 2, save the PC and register. PC is programming content. Yeah. In the PC, the content is the current address for the CPU. Yeah. The step 3, change PC to trap handler. We had saved the PC, so we can change the PC. Yeah. The step 4, execute handler code. The handler code is the interrupt mechanism. The step 5 is restore register and PC. Please remember, restore. Restore is in Chinese we call 恢复. 恢复. 还原. Yeah, restore. Restore register and PC is from the step 2. So if you change the PC, it doesn't matter. We can restore, we can refresh, we can return to the step 2. And if the return is completed, the CPU can run the former programming code. So the problems, you can see what about our catch, but this doesn't matter. We can say this is exception steps. So the 5 steps is effective. Okay, we can see how to save program state. You can see utilize special hardware registers called control and status registers. Control and status registers we can call CSR. Put PC in spec CSR, reason in scope CSR for trap handler to use. As scratch. CSR is point to where we should save program and PC. Address of trap handler given by this CSR special instruction to automatically use this or this is some sentence. This is exception in a pipeline. We can find this is similar to mispredicted branch. You can see there are 5 steps. Step 1, prevent X1 from being collapsed. Step 2, complete previous instructions. Step 3, flush back and subsequent instructions. Step 4, save PC and registers. Step 5, transfer control to handle. This is another kind of handle pipeline pattern. Okay, input and output interrupt. We can see an input or output interrupt is like an exception, except an input or output interrupt is as corneous. More information needs to be conveyed, and as corneous with respect to instructions, execution. Input or output interrupt isn't associated with any instruction, but it can happen in the middle of any given instruction. Input or output interrupt doesn't prevent any instruction from running. Okay. To complete it. He has problem?
He told that Kamala.
Oh, okay. No problem. So pay attention. Please pay attention. The body, the weather is cold, and if you wear the clothes is in Changsha, the temperature isn't even low, but the feeling of body is feel cold.
Because of
this has some use, but they cannot increase your feeling. So you must wear the clothes for winter. You can see some videos and some news from the north of China. The north of China has very, very low temperature, but the feeling we are similar. My wife, my hometown of my wife, hometown of my wife is Hebei province. The location, the position is near in the north of China.
Near to Beijing.
Yeah, when I go to the hometown of my wife, I must drive wear more clothes. It's too cold, and the cloud 风大. Yeah. So this has some clothing feeling. So we must weather the waiting or even some. So in winter we must his weather is small and not even enough. Okay? Interrupt driven data transfer. You can see this is some steps. This is 1, this is 2, 3, 4, 5. So you can find one step is from or become this location, and this is 2, 3, 4, interrupt service routine, include read and store instructions. Okay, this is context switching. The trap infrastructure generalized to switching between processes as well. Operating system can interrupt process at regular intervals, save state of process, then switch to another. Involves a little more work than handling an input or output interrupt. Rule base idea is the same. Okay, this is the example of interrupt-driven input and output. We assume the following system properties: 500 clock cycle overhead for each transfer, including interrupt. Disk thrust of 16 MB per second. Disk interrupts after transferring 16 bytes. Processor running at 1 GHz. If disk is active 5% of program, 1% of processor is consumed by the disk. So you can find this is the calculating steps. The result is 2.5% is busy. So if disk is active 5%, the processor must busy 2.5%. This is the important result. 2% to 5% busy interrupts much better than 40% calling, but still not good enough, especially if I have multiple devices. If I have multiple private devices, the busy is become more and more. Okay, we can see the DMA. This is another solution. Calling vs interrupts. You can see low date rate, high date rate. Low date rate, for example, mouse and keyboard. We can use interrupts to avoid waiting for data. Overhead of interrupts ends up being low. Start with interrupts. Once you start getting data, then switch to calling. Keep grabbing data until it stops. Processor still doing a lot of busy work for data transfer, not idle. So interrupts and calling have shortcomings and have good things. Okay, real solution is DMA. Direct memory access is DMA. So we call DMA mechanism. DMA mechanism we call 直接存储访问. In English we call DMA and direct memory access. So please remember the memory is main memory. The direct is main memory and input and output. So DMA, you can see, device controller transfer data directly to or from memory without involving the processor. In this mechanism, the processor has good things. The processor hasn't doing anything for the transfer. So the processor is like the processor is effective for calculating. Only interrupts only per page. Once transfer is done, you must remember the page is one size.
Yeah.
The page is bigger than bytes. So the page is very useful. But the page is for DMA. Only in DMA mechanism the page can use. You don't use page in interrupt. In interrupt mechanism the page is very big.
Yeah.
So the interrupt can't use page size. This is programmed I/O. You can see this is PIO, programmed I/O. This is DMA. So you can find this is you can find the CPU is in the middle of the PIO and the RAM. This transmitter transfer the procedure of transfer pattern to CPU. So the CPU is effective for calculating, not for transfer. Okay, DMA analog, you can see, let's see, you are busy, don't work, but are getting hungry. You can go to the restaurant, order there, and keep asking them, is it ready yet? This is boring. You can order online, wait for them to tell you your order is ready. Go pick it up and return. This is interrupt. So this is some discrimination for calling and interrupt. Yeah, this is the difference. Okay, new idea is DMA. You can just get a delivery service to handle it all for you. All you have to do is pick it up when the delivery driver interrupts you to see your food is here. So this is DMA. So you can find this is calling, this is interrupt, and this is DMA. So the DMA is new idea for solution. Okay, this is DMA allows input or output devices to directly read or write main memory. New hardware is the DMA engine. We call DMA Controller. This is DMA engine. DMA engine contains registers written by CPU. You can see memory address to place data, I/O device, direction of transfer, unit of transfer, amount to transfer per burst. So this is the operating of a DMA transfer. You can see this the figure 5.4 operation of a DMA transfer. This is step 1, step 2, step 3, and step 4. This is step 5. There are 5 steps. Step 1 is CPU programs the DMA controller. So DMA controller is DMA engine. Yeah, this is DMA controller. It is DMA engine. Okay, CPU gives the controller to the DMA controller. Yeah, the bus controller. CPU gives the bus controller to DMA controller or DMA engine. Step 2, DMA request transfer to memory. DMA send the request transfer to memory. So we can find this is step 2. Step 3, the data can transfer from the disk and the main memory. The disk is one input and output devices. There are several types of input and output devices, and this is the transfer. You can from the disk to the main memory. You can from the main memory to the disk. And step 4, you can find if the transfer is complete, we must send the ARC to the DMA engine. We must let the DMA engine know the the procedure of transfer is complete. We must let the DMA control know. If the DMA control or DMA engine know, we must return the controller to the CPU. So interrupt was done. This is the end of DMA. So the 5 steps, we can see the 5 steps is like interrupt, but there are some differences from interrupt. We can see this is some effective procedure. If the data transfer is starting, the transfer must complicated. We don't interrupt the transfer. Okay, this is direct memory access in modern operating system. This is some example. Okay, in copying data, we can see one is receive. Step 1 is receive interrupt from device. Step 2, CPU takes interrupt, begins transfer. Step 3, device or DMA engine handle the transfer. Step 4, upon completion, device or DMA engine interrupt the CPU again. So, in the middle, CPU can run and run. CPU don't care the DMA engine. But in the start and in the end, CPU must care the DMA engine. Okay, this is outgoing data. Step 1, CPU decides to intimate transfer. Confirm that external device is ready. Step 2, CPU begins transfer. Step 3, device or DMA engine handle the transfer. Step 4, device or DMA engine interrupt the CPU again to signal completion. Okay, this is DMA present overhead. Assume the following system practice 500 clock cycle overhead for each transfer, including interrupt. This throughput of 16 MB per second. DMA interrupt transfer 4 KB. Processor running at 1 GHz. What percent of the CPU is occupied now? You can find this is the result, 0.2 percentage. This is very low. Okay, we can find the DMA problems. If between last level cache and the main memory, we can see last level cache has lower speed. Main memory has low speed.
Yeah.
If the cache and the main memory, we must transfer the data in cache and main memory. We find from don't mess with cache and need to explicitly manage coherency, or just treat like another node in a multiprocessor. Cache coherence is supported by most modern multiprocessors. So you can find this is the cache, this is external memory, this is DMA. DMA is from I/O memory to main memory. The DMA compare cache. So the last level cache and main memory, you can see, don't mess with cache. So we don't care cache. Okay, DMA and CPU sharing memory. How do we arbitrate between the CPU and the DMA engine accessing memory? You can see burst mode, cycle splitting mode, and the transparent mode. Burst mode start transfer of data block. CPU can't access memory in the meantime. Cycle splitting mode. There are three modes. Cycle steering models. DMA engine transfers a byte, releases control, then repeats. Interleaved successes between two. Cycle steering model is popular. We can see the formula is very popular. Transparent mode. DMA transfer only occurs when CPU isn't using the system bus. Okay, we can see the GPIO, embedding input and output. The simplest way for a computer to interact with the physical world is through digital signals it can read and write. A lot of embedding devices can simply combination of buttons and LEDs. A set of pins on a computer chip which can be set to high or low. This is digital input and output. With them to get a 0 or 1, right? Then to set to high or low. LED, this is LED, a blinking code. This is some example.
Rashi,
Yeah.
I want to take a picture.
Yeah. Yes. Okay. This is some C programming.
Yeah.
Yeah. This program coding can control the LED blinking. LED is is like this.
Yeah.
Okay, we can find this is a summary of I/O. I/O gives computers their 5 senses and long-term memory. I/O speed range is 8 orders of magnitude. Input or output methods are many and vary. You can see hard drive disks, solid state drives, GPIO, communicate with devices over memory mapped I/O. We have polling, interrupts, or DMA. So please see and please remember the interrupts or DMA, steps of interrupt, steps of DMA. This is effective. Okay, today we talk about lecture 20. Lecture 20 is input and output. So if you have time, please see this lecture, this PPT, this content from input and output. Interrupts and the DMA have some other content from search engine. You can search interrupt, search DMA from the website. You can see other contents to describe DMA. If you find some flash for DMA, you can learn the DMA mechanism in details. Okay, today is enough. Next, in the Thursday, I'm waiting for you in laboratory. Yeah.